Okay, as a continuation of probability from last time, we're going to learn a little bit about and. And, when you're dealing with probability, is equivalent to multiplication in terms of math. The and basically is determined if you have independent events that occur at the same time. And it's the product of each of the individual probabilities. So, for example, first you get a head, and then you also get another head. Okay, so that would be your probability of getting a head once would be half. Probability of a head a second time would be half again, so a half times a half. So if they're independent, probability is going to be probability of 1, probability of A, which is a half, times probability of B, which is a half, which would be 1/4. Again, if you're flipping coins. How about if you're rolling a die? Okay, dice is plural, die is singular. So we say rolling a die, we're only rolling one of them. So what's the probability of rolling a 4 on a single die? Well, it's 1 in 6, right? One desirable outcome, 6 possible ones, so that's 1/6. So the probability of rolling a 4 is 1/6. All right, what's the probability of rolling a 1 on a single die? Well, that's also going to be 1/6, right? 1/6, all right? What's the probability of first rolling a 4 and then rolling a 1 afterwards? Well, that's going to be 1/6, all right, which is probability of rolling a 4 times 1/6, which is probability of rolling a 1. So 1/6 times 1/6 gives us 1/36, or 2.78%. Again, that's in sequential rolls. First you're rolling a 4, then you're rolling a 1. Okay. Okay, and or is in probability. Or means addition. Or is the independent results occurring individually, but we're adding the probabilities. So if A and B are mutually exclusive, meaning one happens and the other can't happen, okay, then A or B is a probability of A plus the probability of B. And for example, let's that example we just had, rolling a die. So the probability of rolling a 4 we said is 1/6. Probability of 1 rolling a 1 is a 1/6. All right. So if we're rolling a die once, we can have both a 4 and a 1 at the same time on the same die. That's impossible. That's that mutually exclusive. Okay, you can't do both at the same time. So the probability of rolling either a 4 or a 1 on one die is going to end up being 1/6 plus 1/6, okay, which ends up being 2/6 or 1/3, which is 33.33%. Okay, and not is the independent event not occurring. So that would be 1 minus the probability of whatever it is. So the probability of rolling a 1 we said is 1/6. So the probability of not rolling a 1 is 1 minus 1/6, which is 5/6, which is 83.33%. Again, you're allowed to plug these into a calculator. All right, let's say we've got two cards. We're dealing two cards from a shuffled deck. What's the probability? The first card is an ace, and the second card is either a face card or a 10. Well, the probability of first you have an ace, there's how many cards in a deck? There's 52. How many aces in a deck? There's 4. How many face cards? Well, there's king, queen, and jack. That's 3 times 4. 3 times 4 is 12. So 12 face cards. How many 10s? There's 4 10s in a deck. All right. So what's the probability the first card is an ace? That'll be 4 over 52, or 1 over 13, which is 7.69%. This is assuming we took the jokers out, right? Since the first card was not a face, what's the probability of the second one being a face card? Well, now we no longer have 52 cards in a deck, do we? No. So we're not dividing by 52, we're dividing by 51. Okay, so we got 12 face cards in 21, so the probability is 12 over 51, which is 4/17, which is 23.53%. So since the first card was not a 10, what's the probability of that the second card is going to be a 10? Okay, well, there's 4 10s, so 4 over 51 is 7.84%. All right, so the probability of an ace first time around is 7.69. Probability of second time around getting a face card is 23.53. Probability of getting a 10 second card is... Okay, so from that example, we have two cards, all right, dealt. What's the probability the first card is an ace? Okay, all right, so that's where, and. Remember, and we said is multiply, so and is going to be times. So there we go. This is our times. We're going to be multiplying. Probability 1 is an ace, and second card is either a face card or a 10. Remember, or is plus, so or is a plus, which is why we got face card plus a 10. Okay, so probability of getting an ace was 1/13 times 4/17 plus 4 over 51. Okay, we have a calculator, do the math, we get 2.41%. Well, what if the first card was an ace? What's the probability of second card being a face card or a 10? Well, basically, that's this one right here, being a face card or a 10 right here. Just this half before we multiply by 1/13, which is basically, that's just 16 over 51. We use our calculator to do the math. 16 over 51 gives us 31.37%. All right, a conditional probability means, a conditional probability has this line in the middle, okay? Then we write it as P of E bar A. This little line right there is called the bar. So probability of E bar A means probability of E happen given that A happened. So first in A and then in E. So for example, one card is drawn. What's the probability of we get a queen? Well, queen is 4 out of 52, right? Because there are 4 queens, which is 1/13. But if I know it already is a face card, so if I draw it first and it is a face card, what's the probability that it's a queen? Well, there's 4 queens and there's 12 face cards. The probability of being a queen is 1/3 if we know that it was a face card already. Okay, so that's what conditional probability is. So the conditional probability, again, is the probability of 2 events, A and B occurring. Okay, let's say here we've got probability of 2 events, A and B is equal to the probability of B, because B had to happen, and if B happened, basically, if B happened, the probability of A happening. Probability of event A happening, assuming B already did. Okay? It's also, we can also calculate it this way, the same as the probability of A happening, and then if A happened, the probability of B happening on top of that. Okay? So if A and B are independent, meaning they don't rely on each other, then the probability of A and B, remember, and we said would be multiplication, is P of A times P of B. This independent relates back to when we were flipping a coin, because each individual flip coin does not depend on other flip coins. On the other hand, conditional probability matters if you're dealing with cards, because every time you take one card out, it changes, so each one is not independent. So conditional probability would be playing cards. Independent would be an example if you're flipping coins.